Find the reading of the spring balance shown in figure. The elevator is going up with an acceleration of g by 10. The pulley and the string are light and the pulley is smooth. So here there is an elevator, and in that elevator there is a setup as shown. So there is a spring balance, and attached to that spring balance is a pulley. And this pulley has two masses attached to each other by a string. Okay, now what we have to find out? We have to find out the reading of that spring balance. That means how much mass the spring balance will show. Now here if I draw the free body diagram of this pulley, okay, then if I can say this pulley is like this, and this pulley has no mass. Okay, so the pulley is assumed massless. Okay, so here the downward force is 2T, which is acting on the pulley. Okay, now as a result, what will happen? This downward force is acting on the pulley. Then this pulley, as a result, what will happen to this pulley? The pulley will pull the hook which is attached to it with the spring balance. That is, the spring balance hook is there. That one it will pull down. Okay, so as a result it will be pulled down by a force of 2T. So what we have to find out is nothing but the 2T, where T is the tension. So we have to find out 2T. Now let's see how to do that. Okay, suppose there is a person over here who is sitting inside the elevator. Now for this person, this elevator, this frame of reference itself is not a inertial frame of reference, by the way. Why it is not inertial frame of reference? Because it is accelerating frame of reference. That is, the elevator is accelerating. Now when such a case is there, then the Newton's laws of motion do not hold good. So we cannot directly apply the Newton's laws of motion. So for this, what we can do? What we can do is we can use the concept of pseudo force. Concept of pseudo force. So what is a pseudo force? Suppose if I have a frame of reference like this, okay, and in this frame of reference, let's say this frame of reference is S. In that frame of reference there is a particle which is having certain mass m, and there is a force which is towards right direction, which is that of F1. Okay, so F1 force is acting upon mass m in the frame of reference S. Okay, so as observed by the observer of frame of reference S. Now suppose if the frame of reference is also accelerating towards right with the acceleration a0, then for the Newton's laws to be hold good for the observer who is sitting inside this frame of reference, that is the non-inertial frame of reference, what we have to do? We have to add additional force. That additional force will be in the direction of that of the opposite of the the non-inertial frame of reference. That is the acceleration opposite direction. Here it is a0, then to the opposite of a0, that is towards left, there will be an extra force ma0. Okay, now we can apply, we can solve these Newton's laws of, using the Newton's laws of motion, we can solve this problem. Okay, so same thing we are going to do here in this case. So let me copy this elevator picture over here. So I will copy it to the next page. So let's take it to the up little bit. Yes. Now what we will do, I will draw these two masses free body diagram. So here if I draw the mass m1 here, then what are the forces acting on this mass m1? The first force is upward, which is tension, and downward force is that of m1g. Now here, since the acceleration of the frame of reference is g by 10, which is upward, just now as I said, we have to add m1g by 10, which is in the opposite direction of the acceleration of the elevator. So here this downward force will also be there, one more downward force, which is m1g by 10. Note that here this force is indicated opposite to that of the acceleration of the elevator. So now we are done with this. Okay, now we have to write the equation. Now for this particular observer who is sitting inside the lift, he will see that this mass m1 will go up. Okay, by the way, I didn't say the values of mass m1. Okay, this mass m1 is having 1.5 kg mass and mass m2 is 3 kg. Okay, now you can see that the mass m1 will be appearing to go upward because it is lower, right? So it will appear to go upward. Now for this mass, T will be greater than the summation of m1g and m1g by 10 and m1g. So m1g by 10 and m1g. So T will be greater than the summation of that. So now what we can do is we can write the equation. So since T is greater than this summation, we can directly write what is the Newton's law of motion equation. So T minus m1g by 10 plus m1g is equal to m1a. Okay, so this is the tension. Now note here the same tension will be there for the mass m2 because mass m2 is connected by a same string. Okay, now for this particular observer in the lift, the mass m2 will appear to move downwards, right? So for mass m2 I will draw the reference the free body diagram I will draw for mass m2 here. So there is a upward force which is that of the tension, downward force which is m1g by 10 which is the pseudo force, and again another downward force which is m1g which is the gravitational force. Now if I draw this, if I write the equations, first I have to say that let me copy this here. In this case what will happen, I will copy this. In this case what will happen, T will not be greater. Actually m1g by 10 plus m1g, sorry, this is m2, right? So this will be m2 and this will be m1. So here m2g by 10 plus m2g, sorry, not m1, m2. Here it is m2. So here m2g by 10 plus m2g will be greater than that of the tension. Okay, so we can write it m2g by 10 minus, sorry, plus m2g by 10 plus m2g minus T is equal to m2a. Now if we substitute the values of mass m1 and m2, what we will get? I will simply directly write here m1 is 1.5 3 and m1 is 1.5. If I add these two equations, what will be the case? If I add these two equations, then I will get 3g by 10 minus 1.5g by 10 as 1.5g by 10. And here 1.5g plus 3g will be 4.5 times g. So this is equal to 4.5 times a. Sorry, this is minus, by the way. This is minus, not plus. Okay, so if I add this again I will get 1.5 g minus 1.5 plus 3g will be 1.5 g. So 1.5 and g I can take common, so I get 1 by 10 plus 1. This is 4.5 a. Now 15 into 3 is 45. So here what we finally will get is a is equal to 11 by 10 g, okay, with the 3 in denominator. So this is 30. So 11 by 30 g meter per second square. Okay, so this is the acceleration. Now acceleration we got. Now what is the value of t? So value of t can be found out by putting value of a in this equation. So now let's look at this, how we can do that. So t will be equal to 3g by 10 plus 3g. So t will be equal to 3g by 10 plus 3g minus 3a minus 3a. So 3g by 10 plus 3g minus 3a. 3a will be 11 by 30 into g. 3 into 11 by 30 into g. So 3 into 10 is 30. So I will get 11 by 10 here. So 10 into 3 is 30. 30 plus 3 is 33. So 33g by 10 minus 11g by 10 is what I get. So this is 22g by 10, which is nothing but 2.2 g. Now we saw that the tension 2T will be the measured one. Okay, so the 2T will be 4.4 times g. Now if I divide it by the value of g, what I will get? The reading of the spring. Okay, so the reading of the spring will be 4.4 kg. Okay, so this is the answer.